Today we're going to discuss about solving system of linear inequalities. Example, y greater than 3x plus 2, 3x plus 4y greater than or equal to negative 8. So let's begin graphing. So this line right here is already in the form of y equals mx plus b, so we can start graphing it, starting with the y-intercept of 2. Then we look at the slope, which is a 3. So the m is equal to 3, but that's 3 over 1 because we need the rise and the run. This has two meanings, and the two meanings are positive 3 over positive 1 or negative 3 over negative 1. So this is our rise, and this is our run. So let's graph using both slopes. So from here, if I rise 3, then I run 1 to the right because that's positive 1 run. If I use this, I need to go down 3 units and then to the left 1. We're now going to get our ruler and we will connect the dots. For this one, we're going to use dotted line. And the reason for the use of the dotted line is because your inequality has no equal sign at the bottom. So that means that your line is dotted. And your next step is you're going to shade this part right here that is above your y-intercept. And the reason why we're shading the upper part of your line is because this says greater than. So your marker is your y-intercept, and from this point you're going to shade all these above it. This is infinite, so we will just try our best to go as far as we can. Okay. So now the next step is we're going to name our line, and the name of our line is y greater than 3x plus 2. And then now let us go ahead and graph our second line. This one is not in the form of y equals mx plus b, and we are going to transform it into that form. So with that said, I'm keeping my 4y to this side. So 4y stays here. Copy down the inequality symbol. The positive 3x goes to the other side, making it become negative 3x. The negative 8 stays here. And so I divide all of these terms by positive 4. Your final inequality would look like this. And then now we can graph. So we will begin the graphing with the y-intercept of negative 2. And then we are going to go ahead and use the slope. And the slope is negative 3 over 4, which actually has two meanings. And the two meanings are positive 3 over negative 4 or negative 3 over positive 4. Take note that when the signs are the same, your slope will become positive, and if the signs are different, it will become negative. And that's your goal, to make sure that those signs are different if this is negative, the same if it's positive. So now let's use this for a rise and run. Let's use both. We can do both. So from here, we are going to rise 3, 1, 2, 3, and run negative 4. So 1, 2, 3, 4. This is your point. You can now connect the dots, but I still want to go and use this. So negative 3, that means down, and 4 to the right. 1, 2, 3, 4. 1, 2, 3. Okay. You are going to connect the dots, and you will use a solid line. The reason why we used a solid line is because for this particular line, your inequality has an equal sign at the bottom. So this is your second line. This is your first. We're going to name our second line. And this is y greater than or equal to negative 3 over 4x minus 2. So the next step is for you to get a different colored highlighter. And you're going to now shade the upper part of this line, starting with this y-intercept right here. It's upper because it says greater than. So we need to shade all this spot right here above the second line. Okay. In the systems of linear inequalities, you would know the solution by looking at the shading. The intersection of the two shading is where your possible solutions are found. So this spot right here are all the points containing the solutions to the system of linear inequalities. When it's a solid line, all the points on the line are considered uh, are going to be included in the solution set. And if it's dotted, the points on the line are not going to be included in the solution set.